All right, picking right up with Module 9 Nuclear Power, and this is video part 7. And so we are on cementation and disposal. And so once I have it in its brome silicate mix, so it's glass mix, that would go in the center here in its assemblage. And then on top of that, I would then grout it into a cement formula, which would create another barricade. And this is all to keep the radiation material within as best I can in the structure, and then putting it into a safe storage setup. As far as size, here's a little human. Here is my fuel rod. This would be my brome silicate part of the storage cast, and then this would be my cementation matrix cast on the exterior. And so this is sort of my fuel rod assemblage setup within itself. The glass or pyrexing with the brome silicate is a process called vitrification. Vitrification is glassing something, when you glass something. So it's a pretty straightforward, it's actually what it means, right? And then this whole process is known as dry cast storage. Now, dry cast storage doesn't take up a lot of space, but the fuel rods themselves are between 6 and 8 feet long, depending on which nuclear reactor core system you had installed and what year it was made. And so this little facility right here is actually holding 43 years worth of power right here on site. And like I said, we don't have a place to put it right now. And so this is an on-site storage facility, and humans, we can see down here. So we're getting a feel for size, but it doesn't take up incredible amounts of space as far as storing in-house. So that brings me around the fuel cycle, which brings us into disposal. Right now in the US, we do not have any place to put it, and we haven't had any place to put it since we've built these facilities. So we built them back in the 1950s, and we have basically argued about how we're going to finally dispose of these nuclear fuel rods now that we're done with them. And currently in the US, we just let them sit on site. The last plan that we had was known as Yucca Mountain in Nevada. Yucca Mountain was a plan that was scrapped, so we decided not to put anything there. But Yucca Mountain was built, so it's a facility that was built. We spent about 10 years building this facility to dispose of it, and it's almost completed. It was scrapped for good reason, so please don't think it wasn't under good reason, but it's the only form of disposal we had in the United States for our nuclear power waste that wasn't military. So Yucca Mountain is a waste repository. We decided not to put anything in there back in 2010. It means that we, once again, do not have a plan for permanent storage. But as far as where the repository was going to be, it was going to be in this mountain right here. As far as what was going to happen, we were going to take those cast containers that you saw in a previous picture, and we were going to put them into these kind of open cylinder regions underground. And then once we filled them with casts, we were going to weld shut the doors. So we were going to put them in these little lead line tubes and weld it all shut. These are all, once again, artist renditions. And then it brings me to me. So back after 2010 and 2011, 12, 13, and 14, they allowed us to take tours. And I signed up immediately because I'm a nerd and I love this stuff. And so here I am on the tour. This is where we were allowed to take pictures. They actually make you go through a military background check before they bring you to the facility, and you drive your car up over the mountain way up top, and you can see the facility. It's about 4 miles away or 5 miles away at that point, and then they bring you in on a bus. And once you're there, you kind of walk in through the tubing system. And then finally, when you're inside, they put you on one of the trams that they would actually have loaded the dry cast storage on, and they drive you through to show you the facility. And so this is basically it. This is Yucca Mountain. This is from the parking lot, you know. And that brings me to, why is it not safe? And that is because Yucca Mountain is on the fault line. It's on the Juan de Fuca fault line. And it makes it prone for earthquakes. And if those earthquakes rupture open all of this material, it can contaminate. It can contaminate with radiation exposure. It also can contaminate with thorium and barium exposure into water systems if it opened up. And so it was just seen as a not smart location to have built one of these facilities, and a not smart location to put our nuclear waste at. Now, part of the reason why we selected Yucca Mountain, because then the question becomes, why did we waste taxpayer dollars on this location and all of these things, was because Yucca Mountain happens to be a good salt dome within a granite rock, which is great material for putting something that is radioactive into, because it's going to contain radiation exposure. And Nevada as a state is mostly owned by the US. So most of the land is federal land in the state of Nevada, making it very easy for them to take a piece of facility and be able to isolate it and keep populations far away from the location. So that's part of the reason why they picked Nevada and utilized it. Also, with that said, there is other facilities in the United States, or one facility in the United States that is already doing waste storage of nuclear power, and that happens to be military waste. So when we worked out the treaties with Russia to begin our nuclear disarmament, where we were disassembling some of these nuclear weapons, which were very high-grade nuclear weapons, but completely out of date, and so not only were they dangerous as bombs because they could cause a lot of destruction, they also were just dangerous because they were probably going to have malfunctions occur prior to their shelf life, and so it was time to decommission them. And so when we signed this treatise to decommission, we began decommissioning this weapon-grade material, and this weapon-grade material had to go somewhere, which brings us into the facility that we do have in the United States, which is the Transit Waste Processing Facility. And it's an isolated pilot plant. It's known as WIP. And WIP is in Carlsbad, New Mexico. And it is where we hold our waste. And there was a great, I think it was Discovery Channel, actually did a great little bit about this, where they talked about the facility and the processing plant. They were allowed to take a ride down on the elevator itself and come back up. And that's one of the few times they allowed anybody into the WIP facility or even near the WIP facility. But basically, it's as such. It's a processing plant where there's just a surface facility, and then there is an elevator shaft that goes down to where we actually store all of the waste material. And once we fill a shaft, we then weld it shut. So these are actually within itself. Now, the shafts are welded shut, but within the WIP facility, it is also welded within lead boxes. So everything is lead in lead. And this has to do with the fact that it's plutonium. This is highly reactive material. Plutonium enriched well over 8% and could just blow. So these are bombs. And so the radioactive material in these would cause fires. And they would also potentially cause huge radiation releases within the environment, and they could contaminate the air with huge amounts of radiation within the atmosphere if they were to break out. So these suckers are put down in the earth incredibly deep, and just set there under 2,000 feet of earth for its facility setup. So that is why we stick things in the ground. It seems to make the most sense. We don't want to put it in the ocean. That's a dumb move. If it broke open for some reason, we'd pollute our food source, right? And our planet potentially through there. And so we're trying our best to put it somewhere that makes sense. But in the United States at this time, we do not have anything in place that does this. And so it's part of the nature of this topic, and it's part of where politics intertwines with commercial entities and what is best for this country. So on that note, I will see you in Module 10. Please ask any questions and post them in discussions if you have them on nuclear power. And have a good day.